Now, there is another topic that I want to look at while I can, so which is called geometric series. Okay, geometric series. So one of the important example of infinite series is geometric series, which is given as this: a plus ar plus ar squared plus ar cubed plus ar4 plus dot 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 arn minus 1 plus dot dot dot. This is equals to summation n equals to 1 to infinity arn minus 1. Now, provided a cannot be equal to 0. Okay, each term here is obtained by the preceding one by multiplying it with the common ratio n. You can see that. Okay. So if r equals to 1, what do you have? So we have Sn equals to a plus a plus a plus a plus whatever up to a term and a. Now the limit for this, we can see that this term approaches positive or negative infinity. So since the limit of n approach infinity Sn does not exist. So what do you say? The geometric series will diverges for this case. I mean for r equals to 1. Okay. Now how if the r is not equals to 1? If r not equal to 1. So what we have, our Sn is a plus ar plus ar squared plus dot 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 arn minus 1. I multiply by r. So I multiply by r Sn. We have ar plus ar squared plus ar cubed plus arn, right? But the previous term before this will be arn. So this will be multiplied with r will be an, and the previous one will be arn minus 1. Now what happens if you subtract these two terms? Sn minus rsn. So what happens if I subtract that? This is equation 1 and this is my equation 2. Subtracting 1, 2. So we can see that we will have, so whatever term here will be cancelled out, right? This cancels out. I mean, of course, this cancels out, this cancels out, this cancels out, this cancels out, leaving with the first term here. So we have a minus arn. Okay, so what is Sn? Therefore, I can say that Sn is 1 minus r equals to a minus ar to the power of n. So Sn equals to a minus ar to the power of n over 1 minus r. Now we can look at this geometric series here. So let's say I'm looking at the limit n approach infinity Sn here, which is mean limit n approach infinity a. Factor out a, I have 1 minus r to the power of n over 1 minus r. Okay. So when n approach infinity, so what happened to r to the power of n approach 0, right? This term approach 0. So that will gives you a over 1 minus r. Okay. So this is what we can say. Hence, when what I can say, when r less than 1, the geometric series convergent, and the sum is, this is the sum. This is called the sum. Else it diverges for r greater than 1. Okay, I hope that's understood better. Okay, so what can we say here? So we can say that, let's just summarize. So the geometric series what is the geometric series that I've defined earlier on, given as summation n equals to 1 to infinity ar to the power of n minus 1. This is a geometric series where the series are given as a plus ar to the power of squared plus ar to the power of cube and so on, is convergent. If, looking at the positive r, less than 1, okay, and the sum is, this is the sum. The sum for this series here, I'm looking at, when I say sum, is my Sn here. Sn is given by a over 1 minus r. Okay, the sum is, okay, if r is the positive of r greater or equal than 1, okay, we say the series diverges. Okay, so now let's look at example related to this. So the one example can be given as follows. Okay, so the question say find the sum of the geometric series. Okay, so this is given 5 minus 10 over 3 plus 20 over 9 minus 40 over 27 plus dot dot dot. Okay, so what can we say from this from the series here? What can we say? Okay, I can say that this is my A, right? So if I arrange this in terms of geometry series, this is what I have. A plus AR plus AR squared plus AR cubed. Okay, so A is 5 for sure. I know A is 5. Now what is R? How do you find R? So I think I can find R by dividing my second term with my first term. So second term divide by my first term, I can get R. So what I get? Negative 10 over 3 divided by 5. So I get negative 2 over 3. Okay. Now can we say that? Okay, from the earlier on definition here, I mentioned, right? Look at here. This series, geometric series, is convergent if take the absolute of R less than 1. So I've obtained, what is my absolute R here? Which is 2 over 3, which is less than 1. So I know that the series convergent. The series is convergent. Okay, the series is convergent. So how to find the sum? This is the sum. A over 1 minus R. Sn equals to A over 1 minus R. So Sn equals to A over 1 minus R. So what is my A? A is 5. 1 minus R is negative 2/3. So 5 over 1 plus 2 over 3. So this will be 3 over 3, 1 third. Am I correct here? So 5 divided by 1 plus 2 thirds, so 5 over 3, right? So this is what I get. So this will be 5 over 3 over 5, which is 3. Okay, that's the sum. Okay, now let's look at another example. Okay, let's look at a second example. Now the second example is given as this. Determine if the following series converges or diverges. Okay, this is the series. N equals to 1 to infinity, 2 to the power of 2n, 3, 1 minus n. Okay, determine if the following series converges or diverges. Now, this is a bit difficult, right? How can I do this? Okay, now you can start examining the sum of the series here when n is 1. Okay, and so on. But if you look at the term here, is it a geometric series? Now, how do you know if it's a geometric series? Obviously, you'll have something to the power of r or n, something to the power of n, right? That's so I need to do this. So I need to rewrite. So I need to rewrite the nth term of the series in the form of a to the r of n minus 1. Okay, now if I can write that, then I know this is geometric series. Now once this is geometric series, I can determine whether it's convergent or divergent based on my r. Right? Okay, let's play around with this series here. So n equals to 1 to infinity, 2 to the power of 2n, 3 to the power of 1 minus n. Now I want to write it to n minus 1. That's my goal here. So let's write this, change it, the notation here. So I'm going to bracket this term here. Now what happens if I want to write n minus 1? I need to add a negative sign, right? So 3 negative 1 minus n. Okay, like you shouldn't just add negative here, so you gotta factor it out. Okay, what am I doing? Okay, let me just erase this. So if I took out the negative term here, I'm taking out the negative term and rearranging this one, so that'll be n minus 1. Are they the same? 1 minus n. Okay, so if I expand this, negative n plus 1, so 1 minus n. Now they are the same thing. Okay, let's what is a now? So I can say that I can arrange this more now. Okay, so you don't want to have this negative here, so let's rearrange this. How to do this? So what does negative here mean? So I can bring it to my denominator, right? So 2 to the power of 2n over 3n minus 1. Are you with me? I hope you're with me. Okay, now what happened here? I can see that what can I see? The n and n term, you can factor it out, right? So before you want to do that, let's simplify this term here. So I have summation n equals to 1 to infinity. 2 to the power of 2 will be 4n over 3 to the power of n minus 1. Now, to have this n minus 1 term, in order to factor it out, I need to make sure the power here is similar with my denominator. Then I can group this thing. So to do this, so let's write it here. So what happened by adding something like this. 4. Okay, I hope you guys are not getting confused. So this term here is just my algebraic manipulation here, because this is equals to 1, right? 4 to the power of 1, 1 is 4 to the power of 0 is 1, right? But now by having this, what I can do, I can simplify the term here. Okay, so I want to take only the term involving 4n minus 1. So I have 4n minus 1 over 3n minus 1. 4 to the power of 4, bring it front. Do you see that? That's some algebraic manipulation happen here. Oh, I didn't know this can be that long. Okay, therefore, my series now has been simplified to 4, 4, 4. Oh, I gotta write it 4 over 3 n minus 1. Okay, so this is the series that um, looks like a geometric series. A to the power of n minus 1. I mean a to the power of r. A to the power of r n minus 1. So what is a? We know that a is 4 and r is 4 over 3. Okay, the question doesn't want you to find the sum of the series. The question want to ask you to find whether the series converges or diverges. Look at the r here. This r is greater than 1. So therefore, we can say the series diverges. Okay? Now, okay, I think I can go for one more example with the time I have. So let's look at one more example. Okay, now this time I want you to find the value of the series, if it's converge or diverge. So look at this example. N equals to 1 to infinity 9 minus n plus 2 for n plus 1. So first determine whether the series converge or diverge, and then if it's converge, I'll find its value. Okay, so the series doesn't look like geometric series. However, notice that both part of the series term are number raised to a power, right? So which means that we can try to put this in the form of a geometric series. So let's do that. So what we have here, so we want to write it in the form of this geometric series here. Okay, so we have n equals to 1 to infinity. Now I need to take out and make sure this is n minus 1. So I'm going to factor out negative here. So by factoring out negative here, I have 9 negative n minus 2. Okay, and then this is for n plus 1. Now this negative term here, I can bring it to my denominator. So 4n plus 1 over 9n minus 2. Okay, now this term here, so in order to have n minus 1 here, what I can do, so I can write it as 4n minus 1 4 squared. So that will give me n plus 1. Okay, now what about this one? Similarly, n minus 1, n minus 1. That will give me n minus 2. Okay, I hope you're with me. Now, simplifying this, what I have here, I have 4 squared and 1 over 9, which is 16 times 9. Okay, so just write it down. I think I should write it down first. So this is 1 over 9. Well, 9 to the power of negative 1, this is 16. Okay, now simplify the term here. I have summation n equals to 1 to infinity 16 times 9. Okay, for this term here. And I have 4 to the power of n minus 1 over 9 to the power of n minus 1. So we can see that this term gives you a geometric series. 16 times 9 is 144. 4 over 9 n minus 1. So I can say that this is my A here and this is my R. So since R is less than 1, the series converges. Okay, and the value, the sum value will be, you just have to take out the sum value, which is A over 1 minus R.